Hello, in this video we will talk about paired comparisons among treatments in ANOVA. So we know ANOVA is a procedure, is a hypothesis testing, that is to test if the equality of population means from different treatment groups are the same. So the results of ANOVA is reject or not reject this hypothesis. So this H0 is a hypothesis that we assume, for example, all mean from 5 treatment groups are the same. So if the significance tested from ANOVA is significant, then we will reject this hypothesis and say that at least 2 of the means are not equal. For example, this data, we have 5 treatments and with the equal number of sample size for each group. But ANOVA's result does not say which group is different from the others. If we want to know further what's the difference between different groups, so usually we have to conduct so-called paired comparisons. And for the paired comparisons, for example, we can do paired tests one by one for each treatment groups. For example, if we want to know if I and J group have the same effect or not, then we assume with the H0 that these 2 groups have same mean. And if the test is significant, then we will reject this assumption and say these 2 groups are not the same. And the test for paired comparisons comes from t-tests. So we will establish a t-statistic from the sample. So this is mean value from 2 groups. And this is odd sample standard error, S, and this is the group number for sample size. But here we assume all groups have the same sample size. If we look back, so this is the mean value for each group, mean value. And for all the sample, there are 30 observations, we get a sample error S, sample standard error. So if this test statistic is larger than the critical value from t-distribution, for example, t critical value 0.05, then we will say it is not the same for these 2 groups treatment. So in the last sample data, we calculate these 2 mean value from 2 groups, then divided by this variance, sample variance, take square root. So this is the S sample standard error, and this 2 divided by 6 equals 1 divided by 3. Then we take a square root. So this t-value is about minus 1.41. So this p-value is 0.17 and it is larger than 0.05 for the t-distribution with 25 degrees of freedom, because we have 30 observations and for each group treatment lost 1 degrees of freedom. So there are total 25. So in this test we say the assumption between first and the 5th groups are the same. This assumption is not rejected. So we have no significant reason to say that these 2 groups are not the same. So we hold this H0, hold this assumption that these 2 groups are the same. And similarly, we can do many paired comparisons from each paired groups using a t-test. Thanks for watching.